So this is today index. Today is 16. I feel this chapter is still okay lah, and then it's very short actually. If we go fast enough, okay, actually 2 lessons it can finish this chapter lor. Okay, so these chapters there are 2 subtopics. One is a linear system of linear equation in 3 variables. The other one is 3.2 is what? Simultaneous equation involve 1 linear equation and 1 non-linear equation. This one in 2 variables. Okay, so the first subtopic is in 3 variables. Okay, but it's linear. There is no non-linear. There is no non-linear. So all are linear equations. Okay. So first of all, look at this example. Okay, have a look at the prices of the packages offered by a cinema in the advertisement on the right. How do you think how do you determine the price of 1 ticket, 1 bottle of drink, and 1 bucket of popcorn? Okay, so you see, if this one is 1 ticket, 1 bottle of mineral water, 1 bottle of drink, sorry, and then 2 popcorn. Okay, the price is 13. Okay, this is 2 ticket, 2 drink, 1 popcorn. The price is 17. 3 tickets, 3 drinks, and 2 popcorns. The price is 27. Okay, so actually, how you want to find? You want to know the price of 1 ticket and 1 drink and 1 popcorn. You can form the equations or a system of the equations or a system of the linear equation in 3 variables, and then solve it simultaneously. Then you can get the answer. Okay. 3 linear equation can be formed using the variable x, y, and z to represent price of 1 ticket, 1 bottle of drink, and 1 bucket of popcorn respectively. Okay, you got to be very clear every time when you want to form the system of the equations. Okay, you got to very clear what is the x, what is the y, and what is the z. Okay, is the x the number of the ticket, or is the x is the price of 1 ticket? Always the theorem will make mistake on this way. Okay, so here you see the x is the price of 1 ticket. Okay, then the y is the price of a drink. Then the z is the price of a popcorn. Okay, now, okay, the first package here, okay, I can write in this way. Okay, so 1 ticket, okay, so 1 times x, okay, 1 times with the price of 1 ticket, okay, plus 1 bottle of drink, okay, so 1 times y, plus 2 times z, because 2 bucket of the popcorn, okay, 2 times with the price of 1 popcorn. Okay, so add together you will get 13. 13 is the total price of all these things. Okay, then you follow the same way to form the second equation from this, the second package, and then the third equation from the third package. Okay, then you have 3 equations. If you are able to solve it simultaneously to get the x, y, and the z, then you get the answer for the price of 1 ticket, 1 drink, and 1 popcorn. Okay, this linear equation form are known as a system. Okay, a system of linear equation in 3 variables. A system. Okay, a system of linear equation refer to the presence of at least 2 linear equations, okay, which contain the same set of variables. The general form of a linear equation in 3 variables can be written as follows. Okay, so you must understand why they call it a system. It must have at least 2, okay, a system of linear equations. So at least 2 linear equations, okay, and contain the same set of variables. Okay, cannot say The first one is x, y, z. The second one is a, b, c. Then the variable are different. They are not a system of a linear equations. They are different. Okay, they are not in a same system. Okay, this is the meaning of the system. Okay, so the general form of the linear equations, okay, is induced this way. Okay, the ABC is a constant, are not equal to 0. Okay, x, y, z is the variable. ABC is the constant. Okay, means the ABC is a number. X, Y, Z is the variable. Okay, for you to find the final answer, what is X, what is Y, and what is Z. This is the meaning. Okay. Three more girls are not in here. Now it's 9:13 already. Do they aware today got extra class or not? I can see no, Izati is not here. Someone want to ring her? Want to call her? Call her to wake up. She always say she couldn't wake up. I don't know who is the two more girl. You can please help to see around. Okay, who is the two more girls? Okay, and then call them up. Okay, so I come back here. Okay, so this one flashback for you. A linear equation is an equation where the power of the variable is 1. Okay, the power of the variable is 1. Okay, only this one we call it linear equations. Okay, let's see how system of linear equation in three variable can be expressed in a three-dimensional plan. Okay, this maybe I go to this one first. I go to activity 2 first. Okay, to compare system of linear equation in two variable and three variable. Okay, so let you see. Okay, this one you have learned before. Okay, linear system of linear equation in two variable. Okay, so we want to see the graph. Oh, okay, thank you, Yanni. Okay, doesn't matter lah. Okay. Okay, this one is just now the 5 one. Okay, now I change to this bit.ly. So 35. Okay, this is yours. Okay, so you have these two linear equations. Okay, so since you have more than one, so this we call it a system of linear equations in two variable. This one you have to learn during lower form. Okay, so by using graph, okay, we want to show, okay, this is the line and this is the line. Okay, so if we want to solve it simultaneously, okay, so the answer will be here. Okay, if we want to solve it simultaneously, you are looking at the intersection, okay, of these two graphs. Okay, means the answer is here. Okay, so you read down, this is the x value, and then you go to the left, this is the y value. Okay, so this system of a linear equation in a two variable, it can be solved by using a graph method. Okay, and also other methods that you have learned. Okay, afterwards we will touch. Okay, so this is for two variable. Okay, you will see straight line, okay, on the graph. Okay, how about for three variable? What you will see? Okay, I go to another link. Okay, this is the one. Okay, so for three variable, you will not see a straight line. You will see a plan. Okay, like a piece of paper, a plan. Okay, but okay, I will show you one by one. Okay, this is the three linear linear equation in 3 variables. Okay, so I will create one by one. Okay, this is the first one. Okay, the green color one. Okay, you can see like a piece of paper, a blank. Okay, then this is the second one, the pink color one. Okay, these two you can see they intersect at a line here, I hope you can see my cursor. I'm using my cursor to point it. Okay, a line here, they intersect here. Okay, now if three plane want to intersect together, I don't know whether can see or not. Yesterday night I tried. For this example, it's quite difficult to see. Okay, so I want to concentrate the third plane. Okay, any line or any point that they are intersect at this line. Okay, so I call out the third plane. Can't see lor. The blue one you see hiding at the back. It look like not intersect lor. Okay, but don't care lah. The rough idea is like that. Okay, after I will show you one example that they can see quite clear. No, the three plane intersect at a point. Okay, but some are not. Okay, this one maybe got no answer or what. Okay, so the rough idea is like that lor. Okay, so the three plane we want to see where they intersect. That one is the answer for the x, y, and z. Okay, the variables. Okay. Then we come back to the textbook. Okay, so a system of linear equations in 3 variables has 3 axes. Okay, namely x-axis, y-axis, and z-axis. Can you see just now the x and y and z? Okay, Rashika say what? Valerie got dental appointment or cannot join. Rasmi Wi-Fi slow from just now, so it will take some time for her to join. Okay, thank you, Rashika. Okay, so we have all the 3 here already. Okay, so next time when you have like example, Valerie, okay, you have a appointment or whatever that you know already, you can't join today class. Like maybe you know the appointment earlier, you can WhatsApp me earlier so that I aware you can't join, so I don't need to hunt who is that not joining all that. Okay, we come back to this. Okay, can you see the z? Okay, for this they are using the x is how to say, the horizontal one. Okay, the y as the in and out, and then the z they as the vertical one. Okay, so actually normally is you can use either one. Normally we will see the x as horizontal axis and then the y as a vertical axis. I mean here this one is the y, and then the axis in and out because it's 3-dimensional, so we can see the deep, how to say, when we see, how to say, can I say the deep, okay, the depth of it. Okay, so it's an in and out as the z-axis. Okay, so it's like coming nearer to my eyes is like positive, going further from my eyes is a negative. Okay, in and out of the object. Okay, this one is a 3D law. Okay, so we go back to the textbook. Okay, so you have a x, y, and a z axis. Okay, all 3 linear equations form a plane. Okay, like a paper that, like I said just now. Okay, so this is for the 3 variables. Okay, then how about for the 2 variables? 2 variables, I think you are used to it. For the 2 variable, okay, you will form a straight line. Okay, then this one only have the x and the y axis. Okay, so if you can see the picture, yeah, now you see here they use the y as the horizontal axis, z as a vertical axis, and then the in and out axis they use as x. So it can be different, doesn't matter. Okay, as long as you have a 3 axis. Okay, one horizontal, one vertical, and one is coming up. Okay, so for the x and the y axis, this one got no problem. This one you are used to it. Okay. So in general, a linear equation 2 variable can be written in this form. Okay, this is we call it general form lah. Okay, so you have a ax plus by equals to c. Okay, geometrically, when a linear equation in 2 variable is sketched on a plane, it will form a straight line. Okay, meanwhile, linear equation in 3 variables can be written in this form. Okay, ax by, cz, and equals to d. Okay, when sketched, okay, a three-dimensional plan will be formed, okay, as shown in diagram 1b. Okay, so this is the difference in the two variable and the three variable. Two variable and the three variable. Okay, next. Okay, this example is quite easy. Okay, describe whether the following equation are system of a linear equation in three variables or not. Okay, so we look at this. Okay, one more keywords, linear. We will have to make sure this is linear also. Okay, for the A, okay, the answer is no, because there is an equation in which the highest powers of the variable is 2. Now, here it is. Okay, z to power 2. Okay, so this is not a linear. Okay, look at B. Okay, the answer is yes, because all three equations have three variable PQR of power 1. Okay, so PQR all power 1, PQR all power 1, PQR all power 1. Okay, it's just they don't arrange in the general form. Okay, but it's still a system of linear equation in three variables. This one, this exercise we will just go through verbally, so you don't have to do it. Okay, form a linear equation in three variables for the following statement. Okay, anyone want to try? Okay, maybe I let Janice to try again. Janice here. Okay. Can you try these questions? Write a linear equations. Form a linear equation in three variables. Okay, I set for you which one is x, y, and z. Three pair of two shirt and a pair of shoe. Okay, this one is x. The price for one pair of this one is x. Shirt is y, and then this one is z. Okay, the price for one of this is x, one of this is y, one of this is z. Okay, so now can you form linear equations? One linear equation only, not three, one only, because here they only give you one piece of information. Okay, 3x plus 2y plus 1z, okay, equals 750. Okay, thank you. Okay, so correct. And next, Yenny. Yenny, can you answer this? 2a. Okay, explain whether the following equations are system of linear equation in three variables, like the example just now. First, you got to tell me yes or no. Is it a system?
Yes.
Okay.
Yes.
Okay, so you have to explain because they asked you to explain. So explain like just now.
Because all three equations have three variables, m, n, and p of power 1.
Okay, very good. Okay, so I check. Okay, here you have a m, n, and p all power 1. M, n, and p all power 1. M, although this one got no n, okay, but they're still using the same m and the p, okay, of power 1. So this one is still considered is a system of a linear equations. Okay, so next go. I think Izati not here. Sihan.
Yes, teacher.
Can you try B?
Teacher, I'm here.
Hmm?
Teacher, I'm here actually.
You are?
Yes, I just joined.
You are?
Yes.
You are who? Who are you?
Izati.
Oh, you are Izati. Okay, Izati, wait for a while. Okay,
Okay.
let Zihan answer B first.
No,
Okay, why?
because the first equation, the variable f has a power of 2.
Okay, very good. Okay, because of here, this is power of 2. Okay, so the answer is no. Izati, I think it's not fair for you to answer the questions. Maybe you do it next round. Okay, so I asked Rachel to answer the next one. Okay, because you didn't learn it. Okay, so Rachel, can you answer for C?
Yes, it is because all three equations have three variables with power 1.
Okay, so the three variable is what? Please name it.
A, B, C.
Okay, A, B, and C here. Okay, I check one by one. Okay, first one, you have A, B, and the C, okay, all power 1. A, B, and C, all power 1. Okay, A, B, and the C, all power 1. Okay, so the answer is yes. So, Rachel. So, this one done. Okay, next, we want to say this. Okay, before I show you the link, okay, we look at this. Okay, solution to a system of linear equations. Actually, last time you have learned this also. Okay, so it's quite similar. We go through this. There are three types of solution to simultaneous equation in two variables. Okay, when both lines are intersecting, like just now I show you, okay, there is a unique solution, means one solution. Okay, when the two lines are parallel, okay, example like that, okay, then there are no solution. Okay, then the third one, when the two lines are overlapping, okay, overlapping one line, okay, the second line on the top of it overlapping, okay, there are infinite solution. Okay, so for the three variable, the same thing. Okay, solution to a system of linear equation in three variable, the same thing. Okay, one solution, in infinite solution, and no solution. Same like for two variable, there are three types of the solutions. Okay, it can be one solution, no solution, and infinite solution. Okay, so we will see what kind of case you will have these three types of different solutions. Okay, when one solution, the plane intersect at only one point. Okay, for infinite solution, the plane intersect along a straight line, along a straight line. Okay, this is intersect at one point. No solution, the plane do not intersect at any point. Do not intersect at any point. Okay, so we will see into it. Okay, one by one. Okay, we look at the first one. Okay, I go to the first link. Actually, it's inside your textbook also. Okay, so this is the one. Now you see the X, Y, and Z, I think is different again. Okay, I'm not sure, but that doesn't matter. Okay, as long as you have a three axis. Okay, so now, okay, I will call out one by one. Okay, the plan. Okay, this is the first one. Okay, this is the second one. Okay, can you see for these two plans so far I didn't call out the third plan. You concentrate on this line. Okay, can you see they intersect at this line? I hope you can see my cursor. Someone please on the mic can see the mouse cursor or not? Hmm? Yes,
Can, teacher.
okay, thank you. Okay, So you just concentrate on this line because so far these two plane are intersect at this line. So means when the third plane okay, when I call out, okay, the answer will sure confirm fall in this line only one. Okay, so concentrate on this line. Okay, before I call out the third plane. Okay, now is this okay, let us see. Okay, can see or not? Three plane actually only intersect at a point. Okay, just now I asked you to concentrate here. Concentrate here. Okay, so can you see? I don't know whether you can see or not. Actually, the three plane intersect at this point here. Okay, so I call out the intersection point. Okay, here is it. Okay, so for the planes intersect at only one point, you have only one solution. Okay, one solution means you have the x and the y and the z one set. Okay, but one solution. Okay, so this is for the first type of the solution. Okay, now we go to the second type of the solutions, which has infinite solutions. Okay, we want to see the plane intersect along a straight line. Okay. Okay, so first one, second one. Okay, you see so far for these two, I can see they intersect at this line. Okay, now we are going to call out the third one. Okay, okay, see, also at this line. Okay, therefore, if the plane intersect along a straight line, okay, they have an infinite solution. Means that they can have a different set of solution of x, y, z. Okay, so intersecting line. I call out the intersecting line. Okay, this is the one. Okay, this is the one. So this is the second type of form of solutions. Okay, then last one already. Last type of form of solutions. Okay, for this one, you will see the three planes do not intersect at any point. Okay, so we call one by one. This is the first one. Okay, second one. Okay, you can see for these two planes so far they intersect at this line, but when you call out the third plane, okay, nothing. They do these three do not intersect at any point. Okay, I call out the third plane. Okay, why? Because you can see the third plane actually with the first plane are parallel. Okay, if I get rid of the second plane, you can see the first plane and the third plane, they are parallel. If they are parallel, they go in parallel way, means they will not intersect with each other. Okay, it doesn't matter, the second plane, it will intersect with first plane, or the second plane intersect with the third plane, but the three planes will not intersect at any point. This is the problem because the first and the third one are parallel. Okay, so this is the third type of the solutions. Okay, this one got no solution because the plane do not intersect at any point. Okay, so we come back to the textbook. Okay, next we know already. Okay, there are three types of solutions for the two variable, also the same thing. Three variable, also the same thing. Okay, now we want to solve it. Okay, how to solve it? Okay, so this one also same thing. Flashback. Okay, how about simultaneous equations in two variable? Okay, can be solved using the graph graph method, okay, graphical method like just now, okay, and then you remember this substitution method and then elimination method, okay. So altogether 3 methods, but usually graph method we will not use lah, because you need to sketch the graph is not easy, okay. For the 2 variable maybe is still okay, but for the 3 variable you want to sketch a 3D diagram I also don't know how to sketch though. Not that easy okay, difficult to sketch okay. So let us concentrate on this substitution and the animation method okay. So same thing okay, system of linear equations in 3 variables can be solved by finding the value of the variable so that they satisfy all the 3 linear equations. The method for solving our system are same thing, elimination and substitution method. Okay, the 2 methods are the same as the 2 variables. Okay. Okay, so you see the step is similar. Okay, for the 2 variables. Okay, now we see some. Okay, we look at this example. The first example. Okay, they say use an elimination method. Elimination method means you have to find so that how to say, the coefficient for the variable are the same. Okay, if not same, you have to times with a number to make it the same. Okay, so here let me see. Okay, so here they are trying to do is okay, eliminate the x. Okay, they try to eliminate the x. Okay, so therefore you see, you concentrate on the x only. If I can find any of the variable, the coefficient are the same, then easier lah. But I cannot find all. This is 4, 2, -1. This is 3, 1, 2. This is 1, 3, -5. So you know, you just choose one to eliminate lor. Okay, easier one is x is because this is double up. Okay, and then this one also can be double up. Okay, so you just need to times one of the equations, then you can start to eliminate already. Okay, so here they choose first and the second equations. Okay, they multiply the second equation with 2, so that this will become 4x lor. Okay, so that coefficient for the x are equal. Okay, so now the second equation, it becomes this third equations already. Okay, times 2 to every terms. Okay, then after that, eliminate the variable x by subtract the first equation from the third equations. Okay, so this equation and this equation, they do subtraction. Okay, they do third minus the first one. Okay, so if you write back in this way. Okay, this is the third equations okay, and then the first equation. Okay, this is the first equations. Okay, subtract minus. Okay, this is what I will do lah. I put a big circle out the minus sign lah. So means every of the variable I'm going to do minus. Okay, so 4x minus 4x, okay, 0 lor. Okay, 2y minus negative 3y, I get positive 5y lor. Is here. Okay, then 6z minus z, I get 5z. Okay, positive 5z is here. Then 0 minus negative 10 is positive 10. Okay, is here. So now you see, this one you got to keep in mind this one is already in y and z. Okay, no more x. Okay, so this one you keep. Okay, after you're going to use this. Okay, to continue. Okay, then you got to choose another set of the 2 equations. Do the same thing. Okay, eliminate the x. Just now you eliminate the x. Now you also need to eliminate the x. Don't just now you eliminate x. Now you eliminate other things. Okay, then you review the purpose. Okay, so now you see 5 and 6. Actually, this is from the second one. Okay, this is from the second equations. You can still label it as 2 lah if you want. Okay. Okay, then this is from the third equation. Label it as 3 lah if you want. Okay. Then you don't have to label, you know, 1, 2, 3, 4, oh, so many. Okay, so same thing. I want to eliminate the x. So but the x is a different coefficients. So I'm going to multiply the third equations, okay, with 2, so that coefficients of the variable x are equal. Okay, so after I multiply with 2, okay, this is what I get. Okay, then you label, okay, as 7 lah. Okay, is okay. Then you label as 7. Then next 5 plus 7, or the 2 plus 7 actually, okay, means this and this. Okay, you're going to do, okay, plus. Okay, you can write at the side. Okay, this is the second equations. Then okay, this is the okay, 7 lah. Okay, so you do plus. Why you do plus is because here 1 plus, here 1 minus. Why here you do minus is because both are same sign. Okay, so you remember what you want to eliminate. If the same sign, you do minus. If the different sign, you do plus. Okay, so 2x plus minus 2x, okay, you get 0 here. So y plus 4y is 5y. Okay, then 3z plus minus 10z, you get a negative 7z. Okay, and then 0 plus 34, you get 34. Okay, so again, this one, okay, you have to bear in mind. Okay, so now this and this, the one I put a star at the side, these two, you do like your lower form, okay, y and z. So now got no x already, y and the z, okay, you will solve it simultaneously. Okay, so because of the elimination method, now we continue with the elimination method. So 5y and a 5y, oh, so nice. Okay, so you just do same sign, you do minus. Okay, so 4, equation 4, okay, minus equation 8. Okay, so I write at the side. Okay, this is equation 4. I always write like this, easy to see. This is equation 8. Okay, then I do minus. Okay, so 5y minus 5y gone, no? Okay, 5z minus negative 7z become plus. Okay, so I have 12z. Then this is minus is negative 24. Okay, so last step, z is come here, become divide, so negative 2. Okay, so after you get the z, don't stop here. Okay, you got to substitute back. Okay, substitute back where? Okay, for you to find the y, you substitute is inside either the one I put star, okay, 4 or 8, either one. Okay, so here they substitute back to the 8, okay, to find the y. Okay, after that, with the z and the y, okay, substitute back into either 1, 2, or the 3, okay, to get the x. Okay, so then you solve the problem. Okay, so this is an example. So here, this one, if you want to use your calculator, okay, to check your answer, this one you cannot, you know, press calculator and then give me final answer without all this working, cannot. Okay, for you to check the answer, you may use your calculator. But this one, I'm not very sure how to use it. Okay, manual, I don't know where to get the manual also. Okay, if someone try it, you can share with us. Okay, so this one I just leave it. Now we want to see another questions. Okay, just now we are using elimination method. Now we want to use a substitution method. Okay, this is substitution method. Okay, if the question didn't mention what method you use, then you can use any method that you like lah. You feel that easier for you lah. But if the questions mention what method to use, you have to strictly follow lor. You cannot simply use another methods. Okay, substitution methods means you express one of these variable in terms of another two variable. Okay, and then substitute inside the other two equations. Okay, so here they choose z. Okay, express z in terms of x and y. They choose express the z, okay, in terms of the x and y. Okay, which equation they choose? Actually, you can choose from here. You can choose from here if you want to choose z. You can choose from here. Okay, here also is easy because here the the coefficient is 1. Okay, you can choose y also from any of this equation. Also same thing because the coefficient is 1, and then you can choose x also from the third equations. Okay, because the coefficient is 1. Okay, but here they choose it from they choose to use z and then from the first equations. Okay, so z negative z you come to this side. Okay, then the negative 120 go to this side. Okay, therefore you get the 3x minus y plus 120 is z. Okay, then after that, okay, you got to substitute this z because this is from the first equation. Okay, so you don't substitute back into the first equation. You substitute back, you substitute into the second equation or the third equations. Okay, so first of all, you substitute into the second equation. Okay, so your second equation, you see y minus 2z. Okay, y minus 2z. Z, now they no more write z, they write this 3x minus y plus 120. Okay, equals to 30. Okay, this is from the second equations. Okay, and then they write. Okay, they will get another one. Okay, y in terms of the x. Okay, same thing. Why they choose y is because y the coefficient is 1. Okay, so they express y in terms of the x. Okay, so now you have settled. This one is from first equation. This one is from the second equation. So now you got to substitute these two. I put in star one, okay, you got to substitute these two. Okay, sorry, this is from second equation. Okay, you got to substitute these two back into the third equations. This is how you do. Okay, so the third equation is this x plus y plus z. So x is x. Okay, y now you don't write y. Y you write this 90 plus 2x. Okay, plus z. Z now you don't write z. Z you write this 3x minus y plus 120. Okay, again when you see y you don't write the y. Okay, minus the y. Now the y you write 90 plus 2x. So now you see got no y, got no z. Clear. It's only left x. So you can solve for the x. After you solve for x, don't forget to get the y and the z. Always the student stop here, no. They just get the x, then oh happy already, I get the x, I get the answer already. Cannot. Okay, because the question asking for the 3 variables. So what is x? Okay, what is y and what is z? Okay, when you get x, okay, you substitute back into this equation, equation 5, okay, to get the y, and then after that, substitute the x and the y into equation 4 to get the z. Okay, equation 3 can also. Okay, you can substitute into equation 4 also. Okay, anything to get the z. Okay, then you write the solution. Okay, this is for the example 3. Okay, so we have gone through elimination method and the substitution method. Okay, so now next two example I want to show you okay, how we do and then we realize this one is got no solution, and then we do and then we realize this one has an infinite solution. What kind of situation? Okay, because we couldn't draw the three-dimensional graph so by doing mathematical way so how we realize that that one is got no solution or the infinite solution. Okay, so we look at example 4. Okay, this one got no solution this one has no solution okay, when you see this, when you do you get this something like this, then the answer is no solution because 0 cannot be equal to 12 okay, then look at example 5. When you do you get 0 equal to 0. Yes 0 is equal to 0, correct but I still cannot come to a conclusion. Therefore, this one has infinite solution. So now you know already please make notes of it When you see 0 equals 0 means has infinite solution. You see 0 equal to something very weird one okay, then you know this has no solution. Okay, we look at this. Okay, you see here the explanation. Since equation 3 has only two variables, okay, got no x, okay, which are y and z, then the variable x in the equation 1 and 2 need to eliminated. Okay, so this is the reasoning how they start. They want to eliminate, they want to use elimination method, and then they want to start with eliminate the the equation 1 and 2, okay, the x, okay, the variable of the x in the equation 1 and 2. Okay, so how do I eliminate it? Okay, the first equations I got to times 2 wrong. Okay, this is what I get. Okay, first equation times 2. Then after that, you see this is positive, this is negative, so these two equations are going to plus. Okay, so I write out here. Okay, this is second equations. Okay, this is the fourth equations. I think so. Okay, I'm going to do because a different sign, I'm going to plus. Okay, so negative 2x plus 2x, this one gone. Okay, 2y plus minus 2y, so it means 2y minus 2y also gone. Okay, negative 6z, okay, plus 6z also gone. Okay, so here nothing, here's 0. Okay, but 6 plus 6 is 12. This is how you end up with this. Okay, so actually if you see, actually you can see this. Wait, this is what? No solution. This is no solution. Okay, I try to help you in this way. If you see this one, this, we don't look at this coefficient on the right. We just concentrate on this one. Okay, you can see actually this one you times with -2, you will get this one. Okay, so -2 times x, -2x, -2 times -1, you get positive 2y. Okay, -2 times positive 3z, you get negative 6z. This type of system of linear equations has no solutions. Okay, I give you one more example. We go back here. What's the time? Oh, yeah, 54, 54. Okay, I did this one. Okay, same thing. I think the first and the third are parallel, correct? First and the third are parallel. Okay, this, let us see this. And this. Is it? Right. Times 2. Okay, so this one you times 2. Times 2. See, you will get to this one. Okay, so 2x. Okay, negative 4y. Okay, then 0.5 times 2 is 1z. This is why this one also got no solution. Okay, same like just now. Okay, so this one will give you a parallel. Okay, same like just now. That questions. First and the second plan are parallel. These two are parallel. Go to quickly. We go to this. Okay, 5 more minutes. Okay, let us see this. Okay, how they solve it? Let me see. This is the first one. This is the second one. This is the third one. Okay, what they're going to do is, okay, the first one they times 2. What is the purpose? Okay, they want to make the z the same. Okay, because here you see, this is 2, negative 2z, negative 4z, and positive 4z. So the planning is they want to eliminate the z. Okay, they want to eliminate the z. So if this and this, you no need to do anything now. Okay, for this you just have to times 2 lor. Okay, so they do first equation times 2. Okay, so this is what you get. Okay, and then the fourth equation. Okay, the fourth equation means the new equation minus with the second equations. Okay, so this one is the new equations from the first equations. This one is from first equation actually. Okay, they're going to do with the second equations. Okay, this is second equations. Okay, because sign z they want to arrange z, then you look at the sign for the variable z is the same, so you do minus. Okay, so 6x minus negative 5x is 11x. Okay, this one 10y minus negative 2y become plus, so is 12y. Okay, this one gone. Okay, 26 minus 20 is 6. Okay, so this one you just leave it. Okay, then how you get this? How you get this? 1 and 3. 1 and 3, you don't have to do anything to times or what. You just do the animations. So how you want to do? 1 negative, 1 positive. So you how? 1 negative, 1 positive. You do plus. Okay. So the first equation plus the third equations 3x 5y minus 2z. This is first equations. Third equations. This is third equations. Okay, you do minus. Do minus. No, sorry, do plus. Okay, because of different sign. Okay, so this one you get a negative, sorry, got no space. Negative 11x. This one you get negative 12y. Then this one you get negative 6. Okay, 6. Okay, so this is how you get this. Okay, so now these two solve simultaneously. Okay, so again, any variable you can choose. You can choose x or y. Okay, if let's say I choose the x, so different sign. Okay, 11x 12y equal to 6. Negative 11x minus 12y equal to negative 6. Different sign, I'm going to do what? Plus. Okay, so 11 minus 11 gone. 12 minus 12 also gone. So here get 0. 6 minus 6 also gone. You get 0. Therefore, you get 0 equals to 0 here. Okay, 0 equal to 0, then you will conclude this has infinite solution. So I think I cannot continue. Actually, a bit more only. I think you can do it by yourself lah. Okay, just you know, the solving problem questions. Okay, so that same like just now, if you are able to form the 3 equations, then you are able to solve it lah. Okay, so this one will be the homework for today. Okay, and then you can go through this example by yourself. You can go through. Okay, then the solution. Okay, and then this is homework, another homework for today. Okay, then continue. This is another homework. Okay, but how to say? Okay, I want to draw your attention. For this homework, you have to follow exactly. This is animation method. This is substitution method. So here is two questions. Okay, and for solving problem, any method you can use. And then I think something wrong with the questions. Here I want to change the question a little bit. This one not final. This one should be initial. This should be initial. Okay. Then for this exercise, I don't want you to do this. I don't want you to do this. I have too many questions for you, but the rest you do. Okay, except the F I want you to do. Okay, means like A until E no need to do, but you do F. Okay, this one don't do N. Is you do all. You choose either method to do. Okay, I can tell you this question got no solution. This question got no solution. Okay, no solution means what? No solution means that you will get something 0 equals to don't know what, but it's not 0. Okay. Okay. So, but the rest I can't find any other example for no solution and has infinite solution. This is the only example that I can find. That's why I want you to try. Okay. Then the solving problem question number 1, number 3, number 4, number 5, all you do. Okay. So that's all for today. Okay. Oh, I overtime. Sorry, tell your next class teacher. Okay, wait for a while. I stop recording. Okay.